next one is a pretty classic example for us. It says a police cruiser approaching a right-angled intersection from the north. Okay, so we've got the police coming in from the north, approaching this right-angled intersection. Is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection. So now I need to define some variables into here. Again, I'm going to call them X and Y. So when the police cruiser is 0.6 miles north, so that would be at the moment, Y is 0.6 miles. And the car is 0.8 miles to the east, so at the moment, X is 0.8. The police determine with radar that the distance between them and the car is increasing at 20 miles an hour. So now I need to think about that distance between them. We'll call that Z, and we're saying the distance between them is increasing, so a rate is changing, so that's a derivative value at 20 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of measurement, so that's a rate, so that's a derivative value, dy dt is 60 miles per hour, kind of. It's negative because the cruiser is heading south. And we always need to consider direction in our problems. That's one reason why pictures can be particularly helpful. 60 has to be negative because the cruiser is going south, and south is a negative direction as well as west is a negative direction. What is the speed of the car? So how fast is X changing is the question we want to answer. Questions on that? That's kind of our first couple steps. Write it down, define variables, get yourself a picture. Now come up with an equation that relates the variables. So what's an equation that relates X, Y, and Z? X squared plus Y squared equals Z squared, Pythagorean theorem. Plug in anything that's not changing. Can we plug in values for X, Y, or Z? No, they're all changing. So we need to deal with them all and take a derivative. What's the derivative of X squared? 2x, and in terms of time, dx dt. Same for every other variable. Then we can plug in values and hope there's only one thing left and it's what we want. I'm actually going to cancel all of those 2's. If I divide the whole equation by 2, they all go away, and that's just less calculating to need to do. So then X is 0.8. dx dt we don't know. Y is 0.6. dy dt is negative 60. Z is, we don't know Z. And we need to know it. So how can we figure out what Z is?
Pythagorean.
We can just plug it into that original equation, our original Pythagorean theorem equation. We knew what X was, we knew what Y was, so we can do 0.6 squared plus 0.8 squared, take the square root of that. They picked these numbers nicely. What's Z going to end up being? 1. How could we get that without a calculator? It's a special right triangle.
Oh yeah, it's 8, the 6, 8, 10.
It's a 6, 8, 10 triangle, except with a decimal. So Z is equal to 1. And dz dt is 20. So then 0.8 dx dt is equal to 20 plus 0.6 times 60.
Oh, plus the 20.
And then divide by 0.8, and our car is going 70 miles per hour. Problem. They're never going to catch them. The police need to kick it up a notch here and not be afraid to break the speed limit while they're on a chase. So, yeah, I guess they got to slow down to make the turn, but then they're really going to have to kick it up because that car is going faster than they are. So, either that or they need to call in a new unit to block them off somewhere. Because criminals always obey when you kindly ask them to do something.
He can't quite get you. You need to just knock it down 10 miles an hour.
All right.
15 miles.
Yeah, or call back.
Questions? New example.